Hi, welcome to Mathmaxtra. This is Sarita. Today our topic is triangles, and now we will discuss about the triangles, and there are some subtopics in the topic of triangle. What are the subtopics? So we'll first learn what is a triangle and properties of a triangle. And the second subtopic is we'll see what are the different types of triangles. And third topic is triangles and similarity. Triangles, similarity. And fourth topic is triangles and congruency. And fifth topic is triangles, concurrent lines, and centers. Different types of centers. So these are the 5 subtopics we are going to learn in the topic of triangles. What are those? Triangles and properties, types of triangles, and triangles similarity, triangles congruency, and triangles concurrent lines and centers. So the first topic we are going to discuss is triangles and their properties. Triangles and the properties. So first we'll know what is a triangle is. So what is the definition of a triangle? A simple closed plane figure formed by 3 line segment is called a triangle. See, this is one line segment and this is another line segment. This is another line segment. Okay. A, B, C. By these 3 line segment, we are forming a closed plane figure. This we call it as a triangle. In another way, by three non-collinear points, by joining it in a pairwise, a closed plane figure is formed. This we call it as a triangle. So you can have both the definition, that is a closed plane figure formed by 3 line segment, or a closed plane figure formed by 3 non-collinear points. So this is what a triangle is. See, you consider this as a triangle. So what is this? This is a AB line segment. This is BC line segment. This is AC line segment. So these line segments have length. So this length of the line segment, we consider it as a length of the side of a triangle. So these AB and BC, AC, we call them as sides of a triangle. Sides of a triangle. And these A, B, C are vertices of a triangle. We call A, B, C as a vertices of a triangle, and these at the vertex of a triangle, we have an angle. So this we call it as angle A, and this is angle B, this is angle C. These three are internal angles of a triangle. So this we can either call it as simply angle A, or you can call it as a angle BAC. You can either call it as a angle A, or you can also call it as a angle BAC. Angle BAC, and angle B, this is the angle B, you can call it as a angle ABC, and this is angle C, you can call it as a angle ACB. So these three we call. So how many number of triangles can we form by joining three non-collinear points? Just now, as we said in the definition, we can form only one triangle with three non-collinear points. See, these are the three non-collinear points. You can form one triangle by these three non-collinear points, isn't it? Then, how many number of triangles can you form by n non-collinear points? So in the topic of line segment, we have seen in order to form a line segment, we need 2 points. In order to form a triangle, we need 3 points. So how many number of triangles can you form by n non-collinear points? So there are NC3 number of triangles we can form by joining n non-collinear points. So how many triangles can you form? NC3. NC3 number of triangles you can form by joining n non-collinear points. Then how many number of triangles can you form with n collinear points? See, these are the three collinear points. Okay. How many number of triangles can you form by joining these three collinear points? We'll see. See, this is one line segment, okay. This is one line segment, okay. And this is another line segment, okay. Is it a triangle? No. Because see, we are just forming a line segments, but it is not forming a closed plane figure. That is why we can't form even a single triangle by a n collinear points. Not only with three collinear points, even if you take n collinear points also, there is no possibility of forming a triangle. That is why the answer for the question, number of triangles we can form by n collinear points is 0. Okay. So similarly, you can form how many number of triangles can you form with the given n points in which m are collinear. Means there is a restriction. Total n number of points are there. Out of n m are collinear, and other than the m points, we have non-collinear points. Then how many triangles can you form? See, we can form with n points, NC3 triangles can be formed, but in which m are collinear. That is why you subtract MC3. So this many number of triangles we can form with n points, out of which m are collinear, because we don't form any triangle by m collinear points. That is why this many triangles we can form. Okay. Then similarly with the 3 points we are forming a triangle. With the in order to form a quadrilateral, how many points do you require? 4 points, right? So with 4 points we can have 4 line segments, and by 4 line segment we can form a closed figure which we call it as a quadrilateral. So at that case, how many quadrilaterals can you form by n non-collinear points? Which is nothing but NC4 quadrilaterals you can form. Similarly, not only quadrilaterals and pentagons. For pentagons, 5 points are required. So how many pentagons? If the question is how many pentagons can you form, you can simply say NC5 number of pentagons can be formed by n non-collinear points. Okay. So this is what about how many number of triangles are formed by n non-collinear points. Okay. Now we'll see parts of a triangle. What are the parts of a triangle? Parts of a plane. Parts of a plane with respect to triangle. With respect to triangle. See, you consider this as a plane. So you are drawing one triangle A, this is B and this C. So this is the plane C. This is the plane we are considering. In this is a triangle. This triangle dividing this plane into three parts. So what are those? This we call it as a exterior of a triangle, isn't it? Which is nothing but outside of a triangle. That is why we call this as a exterior of a triangle. The points on this region, the points P, Q, R, S, T. These P, Q, R, S. So these are where the points are lying. These points are lying outside of the triangle. That is why we call them as a exterior points. Exterior points, because these points are lying exterior of a triangle, and you can have some points inside the triangle U, V, W. So these points are interior of a triangle, because this region is interior of a triangle. So the points which are lying interior of a triangle, we call them as a interior points. Though the points U, V, W, these points we call it as interior points. Interior points. And you can also have one more part which is on the triangle, which is nothing but on the boundary of a triangle, on the boundary of a triangle. A, B, C, D, E, F. Yes, see, A, B, C, D, E, F. So these are lying on the boundary of a triangle. That is why we call them, those points are on the triangle. On the triangle. The points are on the triangle. Points are on the triangle. So these are the different parts of a triangle, which the these are the parts of a plane with respect to triangle. Means this triangle is dividing this plane into three parts, which is exterior part, this is interior part, and this is the on the boundary part. Okay. This is what a triangle and its parts. Now we will know what is an exterior angle of a triangle. So just now we have seen So this is a triangle A, B, C. So these are interior angles we are considering. Yes. And it has total 6 parts. What are those? 3 sides, 3 interior angles. Total 6 parts of a triangle. So if you extend one of the side, AB is one side, BC is one side, AC is one side. If you produce this BC side to some other point D, see this is the point D, we are producing this BC side up to D. So the angle thus formed is called exterior of a triangle. Exterior angle of a triangle. See, this is the exterior angle. So what is exterior angle? If you produce one of the 3 sides of a triangle to some other point, the angle thus formed is called exterior angle of a triangle. So this we call it as the interior angle, which is nothing but angle ACB, and this angle is called exterior angle, that is angle ACD. So see how many exterior angles can we form for a triangle? It has 3 internal angles that we know very well. So but how many exterior angles can we form? It has 3 sides. Yes, we can produce either this side, or you can produce either this side, or you can either produce this side. So how many exterior angles we can form? So this is up to E point and this is up to F point. Yes, we can form this exterior angle, and you can form this exterior angle also. So there are 3 exterior angles you can form by producing 3 sides of a triangle. So how many? It has 3 interior angles and 3 exterior angles are formed at the vertex of a triangle. So what is the, see at the vertex, this is the vertex A. At the vertex, this is the internal angle, this is the external angle. So total complete angle, what it represents? This is a straight line. So one straight angle it is forming. One straight angle it is forming. That is why we call it as a sum of the interior and exterior angle which is equal to 180 degrees, means the internal and external angles are supplementary to each other. So you can have angle, see angle EAB. EAB is exterior angle. EAB is one exterior angle, and angle BAC. Angle BAC is interior angle. Sum of these two angles is equal to 180 degrees. That is, the internal angle and external angles are supplementary to each other in any triangle. Okay. Now we will discuss about different properties of a triangle. So a triangle has many properties. These properties of a triangle will help you a lot when you solving the problems in geometry. So we'll see the first property. What is the first property? The sum of inter, interior angles. The sum of interior angles of a triangle is equal to, is always equal to 180 degrees. So what is the first property? The sum of interior angles of any triangle. You take any triangle, the sum of the interior angles is always equal to 180 degrees. So how can we say the sum of the three angles are always 180 degrees? Now we'll see. So you take one triangle. This is a triangle. So these are the vertices of a triangle. This is vertex A, vertex B, vertex C. We know these angle A is an interior angle B is another interior angle, and angle C is another interior angles. Now we have to show the sum of these three interior angles which is equal to 180 degrees. So how can we prove the sum of the interior angles is equal to 180 degrees? See, so you draw one parallel line to this BC. So you draw one parallel line. Okay. So this line is parallel to BC. So as these two are parallel lines and this we are considering it as a transversal line which is meeting these two parallel lines. Yes, this is we are considering AC is a transversal which is meeting the line A and BC. Yes, so we have theorem, corresponding angles theorem. In that we have seen if a transversal meets two parallel lines, corresponding angles are equal, alternate angles are equal, allied angles are supplementary. So here what this is, so these two, so this is angle C we are considering, this is angle A, this is angle B. See, this is these two are alternate angles, right? So that is why these two are equal. We can, I am writing this is which is equal to angle C. Okay. So similarly, you consider this transversal, this AB transversal, which is meeting these two parallel lines. This is one line and this is another line. So this AB transversal meeting these two parallel lines. So the similarly these two are alternate angles. This is and this is, these two are alternate angles. So these are equal by the corresponding angles theorem. So this is angle B. Yes. So this is angle B. This is angle A. This is angle B. And this is angle C. So by these three angles are forming a straight angle at the vertex A. Isn't it? See, this is a vertex A and it is forming a straight angle. See, this is a straight angle. So the straight angle measures 180 degrees. Right? We have seen what a straight angle measures. Straight angle measures 180 degrees. That is why we can simply say angle A plus angle B plus angle C, which is always equal to 180 degrees. See, angle A plus angle B plus angle C, which is always equal to 180 degrees. This is the first property of a triangle. Now, the second property is, what is the second property? We have seen what is an exterior angle of a triangle. Yes. So this is a triangle ABC. Yes. We are extending this BC is produced to point D here. So thus the angle is formed here. This angle we are considering it as an exterior angle. Yes. So this exterior angle, this exterior angle which is always equal to sum of these two interior angles at the other two vertex. So the exterior angles This is the exterior angle forming at the vertex C, which is always equal to sum of the interior angles at the other two vertex. Yes, other two vertices. See, so which is equal to nothing but angle A plus angle B. Yes, this is angle A we are considering. This is angle B and this is angle C. See, we are extending this line. It is produced to D. So here external angle is forming. So this exterior angle which is always equal to sum of the two interior angles at the other two vertices. Yes. Now you produce this AC. This is up to E. So here one more exterior angle is forming. So what is this equal to? Sum of the interior angles at the other two vertices. This is the exterior angle at vertex A. So which is always equal to sum of the interior angles at the other two vertices. And you extend this AB again to some other point F. Again one exterior angle is forming. So this exterior angle at the vertex B, which is equal to sum of the interior angles at the other two vertices. So which is equal to angle A plus angle C. So this is the second property of a triangle. So what is it? Always the exterior angle at the one vertex which is always equal to the sum of the two interior angles at the other two vertices. Okay. And you can simply write this is equal to, just now we have seen this interior angle and exterior angle at one vertex which are always supplementary to each other. So that is why you can write this as a 180 minus angle A, right? Because sum of these angles, this is the interior angle, angle A, and this total sum of this angle B plus angle C is the exterior angle. So sum of these two angles which is always equal to 180 degrees. So this is simply equal to how much? 180 minus angle A. Similarly, this is equal to 180 minus angle C and this is equal to 180 minus angle B. This is how we can represent exterior angle at the vertices of a triangle. Okay. Now we'll see the third property of a triangle. What is the third property of a triangle? So sum of all the exterior angles of a triangle which is always equal to 360 degrees. So the third property is sum of all exterior angles of a triangle. Sum of all exterior angles of a triangle always equals to 360 degrees. See, so this is the third property, that is sum of all the exterior angles of a triangle is always equal to 360 degrees. See, just now we have seen A, B, C, and this is producing to E and this we are producing to F. So this is one exterior angle and this is angle C, angle A, angle B, and this we are calling it as a angle A plus angle B, and this as a angle B plus angle C, and this as a angle A plus angle C by the previous property. So now we have to prove the sum of three exterior angles which is always equal to 360 degrees. Now you write what are the exterior angles? See, this angle plus this angle plus this angle. So you write angle A plus angle B plus angle B plus angle C plus angle A plus angle C. So what it is equals to? 2 types of angle A plus 2 times of angle B plus 2 times of angle C. So 2 times of angle A plus angle B plus angle C is equal to 2 times of, this is nothing but sum of the interior angles of a triangle, which is always equal to 180 degrees. So which is equal to 2 times of 180, 360 degrees. By this we can prove the sum of all exterior angles of a triangle is always equals to 360 degrees. Now, the fourth property is you take a triangle, so the angle opposite to the longest side, the angle. Suppose you consider this is a 14 centimeter and this is a 12 centimeter and this is a 10 centimeter. So which is the longest side? This is the longest side. The angle opposite to the longest side is greatest and the angle opposite to the smallest side is shortest. See, this is a angle opposite to shortest side. So among these three sides, 10 centimeter is the shortest side and 14 centimeter is the longest side. So the angle opposite to 14 centimeters is greatest angle and the angle opposite to the smallest side is shortest. Yes. So, so what is angle A is always greater than angle B is greater than angle C. Yes. So by these sides you can identify which angle is greater. This is one property. Okay. So the next property is, fifth property is converse of the fourth property. That is, if we know the angles, these two properties tells us about the relation between the sides and angles of a triangle. So in the fourth property, we are first we know about sides. Now we are estimating which angle is greater, which angle is smaller. So in the fifth property, so we know angles. Somewhere here 70 degrees, this is 50 degrees, this is 60 degrees. So now we know angles. Now we should have an idea about the sides which are opposite to those angles. See, this greatest angle, the side opposite to greatest angle is longest. So now this BC side is greater compared to other sides because the angle here is greater. Yes, among these three, 70 degrees is the greatest angle. So the side opposite to greatest angle, which is always longest. So by this you can simply write BC, which is greater than. So the side opposite to angle C is what? AB, which is greater than. So this is the smallest angle among these three. So the side opposite to smallest angle is small only. Okay. So 50 degrees के opposite side is AC. Yes. So this way we can relate angles and sides by these two properties. Okay. So the next property is sixth property. In the sixth property, you take one triangle. Usually we use the convention of writing sides with a small letters. So this is the side which is opposite to angle A. So that we represent it with a small a, and the side opposite to capital B angle we represent it with small b, and the angle C, here the side opposite to angle C we represent it with small c. So these small a, small b, small c represent lengths of the sides. Okay. So this is how we represent. So the sixth property is thus you take any two sides of a triangle. You take a plus b, sum of any two sides, or you can take b plus c, or you can take a plus c. Yes, which is the sum of any two sides, which is always greater than the third side. See, a plus b, sum of these two sides, which is always greater than side c, and sum of sides b plus c, these sum of b plus c, which is always greater than side A, and the sum of A plus C, sum of these two sides which is always greater than side B. So this is the property of a triangle. So you take any two sides of a triangle, the sum is always greater than the third side. Okay. So the seventh property. In the seventh property, we take a difference of a sides. So you take any two sides. So if you take the difference of two sides, which is always smaller than the third sides, you take these two sides. So a minus b. But we don't know which one is greater, whether a is greater or b is greater. That is why we should keep mod for this difference. Just to represent, we should keep mod. Yes. So which is always less than the third side. So the seventh property is, if you take any two sides of a triangle, the difference of those two sides which is always less than the third side. Yes, you can write the difference of sides B and C, which is always less than A, and you take the difference of sides A and C, which is always less than the side B. So this is one property of a triangle. Okay. So in the sixth property, we have seen sum of the two sides which is always greater than the third side. In the next property, we have seen you take any two sides difference which is always less than the third side. Okay. Now, next property, which is eighth property is, so the third side, thus any side which is always between the sum of the other two sides and difference of the other two sides. Okay. So you take C. So this C, length of this side C, which is always between difference of the other two sides C, A minus B. This is the difference of other two sides and sum of other two sides. So always the length of the side between the difference of the two sides and sum of the two sides. So this property will help you a lot while solving the questions. Okay, this you have to remember. And the next property is, so in the next property, you take, in this, you take these two angles are equal. So this angle and this angle, these two angles are equal. Okay. So if these two angles are equal, the sides opposite to these angles are also equal. See, if angle B is equal to angle C, means these two angles are equal, then the sides opposite to this angle, then the sides opposite to this angle, which is AC equal to AB. So this is the next property is converse for this. you have one triangle in this. These two sides are equal. So if these two sides are equal, then the angles opposite to those sides. See, this is the angle opposite to this side and this is the angle opposite to this side. Okay. So the angles opposite to the same sides, equal sides are always equal. Means if BC is equal to AC, if BC is equal to AC, the angle opposite to these sides, that is angle A, which is equal to angle B. So these are the some of the properties of a triangle. Okay, thank you.